Now, let's take a look at how to bridge the gap between design and manufacturing side. Customers, they might ask some questions. So, okay, so if the customer might ask, if we have a lot of identical machines and we do machine characterization for all of them, how can I properly build a database, a machine database in my software? So we have this serial number. This is a friendly tool that in our machine MMIP file, we have this serial number. So customers, they can provide us this serial number in their real production site. So even if they use several identical machines, but they might have a number for each machine. So maybe they have 10 identical machines and they will be labeled from 1 to 10. So in our MMIP file, we can set up this serial number from 1 to 10. So they can import all these machines into their database. And with this serial number, they can quickly find the right machine that they want to use for their simulation. Okay? And another question the customers, they might ask is, why do we need just one mold and one material? Why isn't it enough? So this concept is very similar to our autopilot in our car. So for our autopilot in our car, when we set up a speed, we set up a one constant speed. So on a flat surface, flat road, regular road, the car will remain a constant power. When we climb uphill, in order to maintain the same speed, the car will increase the power input and apply more power to maintain the same speed. When it goes downhill, the car will reduce the power and apply some brake to maintain the same speed. This concept is the same in injection machine. When we set up a constant velocity in our injection machine, the machine will try to maintain the velocity. So even if we change the mold, so let's say a smaller part, it's more difficult to fill the cavity. In order to maintain the same speed, the machine will automatically increase the power, increase the sprue pressure by itself. If we change the material, for example, a material with a lower viscosity that is easier to fill, the machine will automatically decrease the power, will lower the power, will lower the pressure, and maintain the same velocity. So this is pretty much the same concept as a car. So we don't have to run experiment with a lot of different mold and a lot of different material, because under different condition, our machine will automatically adjust itself to fit different mold and different material. Okay, and another question the customer might ask is, how can I use this MMIP file in my simulation software to consider machine response? How can I use it in Moldex3D? Is it complicated? Okay, so once the customers, they get the MMIP file, they can simply use the machine mode and import the MMIP file. Once they import it, it'll be imported into the database, and they just have to select this machine, and all the rest remains the same. All the other settings remains exactly the same. So this is the only extra step. So extremely simple. Only three clicks. Click import and choose and click on the machine and click select. With 3 extra clicks, users will be able to use this MMIP file in Moldex3D. And then in the result, they will be able to see the difference. So the green curve is the ideal velocity. So without considering the machine response, if if we use a perfect condition, the simulation will give you this kind of injection velocity, exactly the same as the setting. So that's the green curve. But when we consider the response, it'll be this red curve. This red curve, there's a peak and it goes down and it goes up again. So with considering the machine response, the response curve will be very, very different from the ideal situation, and it'll be closer to this blue curve, which is the real machine response curve. Okay, and not just injection stage, also the packing pressure will be the same. So even if we change the setting, we use different packing pressure setting, 40 megapascal or 15 megapascal, we can see we can always perfectly capture the machine's behavior. Okay, and not just the injection and the pressure, also the VP switch point. So for the real setting, in this case, we set up the VP switch at 2.1 seconds without considering machine response. In the log file, we can see the simulation gives us a VP switch at 1.5 seconds. With considering machine response, the VP switch time is around 2 seconds, which is much closer to the real setting. Okay. Now, the customer might ask, if I have the same machine, the same spec, with the same machine maker, and I use the same mold, I use the same material, same process condition, shouldn't they behave the same? Do I really have to do machine characterization for each one of them? So here we have done a test with two identical machines. Machine number one, the VP switch is at 4.22 seconds. Machine number two, the VP switch is at 2.62 seconds. If we look at the beginning of the injection, as we can see, machine number one has a delay time of a little over 1.5 seconds. But machine number two, the delay time is actually less than 0.5 seconds. So even if they are two identical machines, they have different response time. And not just the response time, if we look at the injection stage, this machine number one, they have two peaks. The first peak is higher than the second peak, as you can see over here. But machine number two, the same, it also has two peaks during the injection stage, but these two peaks, they have the same injection velocity value. So these two identical machines, they have different response time, and also they have different velocity value response. So even if we have identical machines, we recommend users to do separate machine characterization service. So the question here is, how can we transfer the process condition from CAE software to manufacturing site? Because for CAE engineer, when they set up the process, it looks like this with a simple CAE mode. So the interface looks like this. But for process engineer in the manufacturing site, they use a mold tryout table. So they look completely different. So the question right here is, how can I transfer the temperature, the VP position, the velocity setting, and the pressure setting from CAE software to my machine? And there are a lot of difficulties in between, because for different machine we might have different units. We have millimeter per second. For some machine we have percentage for the velocity setting, and for pressure control, some machines they use bar, some use megapascal, and some use percentage. So how can we transfer from CAE software interface to my real machine? For Moldex3D, you don't have to worry about this, because we have Moldex3D machine interface. We create this interface that is exactly the same as your real machine. So CAE engineers, they can set up the process using this simple interface in our software, and automatically transfer these settings to our machine interface in Moldex3D. They can automatically transfer the setting, process condition setting from this interface to this real machine interface. And with this setting, the CAE engineers, they can simply take pictures, they can pass these screenshots to the process engineer, and they can put it into their real machine. Okay, so by doing so, we can close the communication gap between CAE engineers and manufacturing sites.